Okay, so in this lecture, I'll show you one more problem for finding a solubility product from solubility. Okay. What we had discussed in the last lecture is that if solubility is given in molarity, okay, in mole per liter, yes, we can find solubility product directly by using the formula Ksp equal to x to the power x, y to the power y, and s to the power x plus y. Okay. Instead of mole per liter, suppose if solubility is given in gram per liter, right, how to calculate Ksp? Okay, we will discuss this with a simple problem. Okay. Okay. So let me give an example here. Suppose I'll take lead iodide. We know that lead iodide is sparingly soluble in water, and the solubility of lead iodide in water, in pure water, it is given as 0.55321 gram per liter. This is solubility of lead iodide in pure water. Now solubility is given in gram per liter. We need to calculate Ksp. Remember, to calculate Ksp, okay, we need to convert solubility from gram per liter into mole per liter. Okay, so how to calculate solubility? How to convert gram per liter into mole per liter? Very simple. We need to divide this value by the molar mass. Okay, if we divide, this is gram, no, gram means mass. If we divide mass by mole, molar mass, I'll get number of moles, correct? So what is the molar mass of lead iodide? Molar mass of lead iodide is 461.01. This is molar mass of PbI2. So if I divide this value by this, what we get is we get the value as 1.2 into 10 power minus 3 roughly. So this is this much mole per liter. So if solubility is given in gram per liter, first convert gram per liter into mole per liter by dividing the given value by the molar mass. Okay, then we can calculate solubility product. How? You know, Ksp equal to x power x, y power y, and s to the power x plus y. Okay, and lead iodide will give 1 Pb2 plus ion on ionization and 2 iodide ion. So cation is 1, x equal to 1, anion we get 2 anion, so y is equal to 2. Therefore, if I use this formula 1 power 1, 2 power 2 is 4, and s power 1 plus 2 is 3. So the answer is 4 into s power 3. This is the relation, I'm sorry. The relation between solubility product and solubility. Now what we should do? 4 into, what is solubility? 1.2 into 10 power minus 3 molarity power 3. Okay, if I simplify this, we get 6.5 into 10 to the power minus 9. Okay, and this is the solubility product of lead iodide. Listen, I didn't give you the temperature. This is at 25 degrees Celsius, right? The solubility data is given at 25 degrees Celsius, and the solubility product constant which we calculated using this data, it is also applicable only at 25 degrees Celsius. I have already told you solubility product depends on temperature. As the temperature changes, solubility product value also will change. Okay, now, okay, so in the previous problem, solubility is given in gram per liter. So to calculate Ksp, first convert solubility in gram per liter into mole per liter. Then we should find out solubility product constant. Now, if solubility product constant is given, how to find the solubility? Okay, so let me take a problem here. So what I'm going to do, if solubility product is given, how to calculate solubility? Right? Yeah. So let me take a simple problem. Suppose I'll take calcium carbonate. Okay, calcium carbonate. Calcium carbonate solubility product constant is equal to 3.8 into 10 to the power minus 9 at 25 degrees Celsius. Right? Now we need to find out what is the solubility. Okay, so calcium carbonate will give one calcium ion, so X equal to 1, and one carbonate ion, so Y equal to 1. Therefore, the relation between solubility product and solubility is 1 power 1, 1 power 1, S power 1 plus 1, it is 2. So 1 power 1 is 1, this is 1, so I'll get S square. Okay, Ksp equal to S square, or S is equal to square root of solubility product constant. So which is equal to square root of 3.8 into 10 to the power minus 9. Or I can write this as multiply this by 10, divide this by 10, so I'll get 10 power minus 9 here. Square root of 38 into 10 power minus 10 will give me 6.1644 into 10 to the power minus 5. Okay, square root of 38 and square root of minus 10 will give me this. So I will get the answer in mole per liter. Remember this is very important. From solubility product constant, if you calculate solubility, we will get the answer in mole per liter in molarity unit. If you want the answer in gram per liter, okay, what you have to do? Multiply this by the molar mass. Okay, so this is solubility in molarity unit or in mole per liter. Okay, so what is the solubility in gram per liter? What we have to do? Take the value 6.1644 into 10 to the power minus 5. This is in mole per liter. Multiply this value by the molar mass. Okay, for calcium carbonate, very well we all know that molar mass of calcium carbonate is 100. So this is molar mass of calcium carbonate. Molar mass of calcium carbonate. If you multiply this by 100, we get 6.1644 into 10 to the power minus 3 gram per liter. Okay, so from solubility product constant, we can find the solubility. Okay, now I'll do one more problem so that you will be a little comfortable about this concept. Let me take another problem. See how to calculate solubility from solubility product constant. Right. So now I take lead chloride, PbCl2. You know very well, lead ion is in qualitative analysis. Okay, for basic radical, lead ion is precipitated in the group 1 as lead chloride. Okay, for lead chloride, the solubility product, and you know very well, for most chlorides, solubility product constant is somewhat high. Whereas for lead chloride and silver chloride, for some metal ions, right, the solubility product value is very low. Okay, for example, in the case of lead chloride, solubility product constant equal to 1.6 into 10 to the power minus 5. Okay, now how to calculate solubility from this? We know very well, lead chloride will give one cation, X equal to 1, and it gives 2 anion. So lead chloride, one molecule of lead chloride gives 1 Pb2 plus ion and 2 chloride ion. So X equal to 1, Y equal to 2. Now what is the relation between Ksp and solubility? Ksp equal to X to the power X, Y to the power Y, and S to the power X plus Y. This is general formula. Right, now we know the value of Ksp, which is 1.6 into 10 to the power minus 5 equal to X value is 1. So 1 power 1 is 1. Need not write, just put 1. Then Y power Y, 2 power 2 is 4. Then S power X plus Y, which is 3. Okay, so we need to find out solubility. So S cube equal to 1.6 into 10 to the power minus 5 by 4. Or S is equal to cube root of 1.6 into 10 to the power minus 5 by 4. Okay, we can make some simplification here. Cube root of, if I multiply this by 10 and divide by 10, I'll get 16 here and 10 power minus 6 here by 4. Okay, 1 4s are 4, 4 4s are 16. So we need to find out the value of cube root of 4 into 10 power minus 6. Okay, so we can find this value. Right, what we can do, we will make some other simplification here. I multiply this by 1000, so I will get 4000, and divide by 1000, I will get 10 power minus 9. Okay, so what is the cube root of 4000? They can read. Yeah, so this value, cube root of 4000 is 15.87 into 10 power minus 9 cube root is 10 power minus 3. Okay, so if I can write it in this form, 1.587 into 10 to the power minus 2, okay, molarity, this is 2. Right, what I did? I divided this value by 10 and multiplied by 10. So 1.587 into 10 power minus 2 molarity. This is the solubility of lead chloride. Okay, at 25, this data at 25 degrees Celsius. This is solubility. So we got the value in molarity. Now to get the value in gram per liter, what we should do? Let me do it here. Multiply the value 1.587 into 10 power minus 2. This is solubility in molarity. To convert into gram per liter, multiply this value by the molar mass of lead chloride, which is 278.1. So if you multiply, we get the answer comes out as 4.41 gram per liter. This is the solubility of lead chloride in pure water at 25 degrees Celsius. Okay, and the value is given in gram per liter.